Hello and welcome to another exciting Breakfast with Unity. I'm your host Max Moreau, and we're going to place some objects on a surface. I'm trying to kind of get a split in this show between doing just cool stuff, random stuff that's not particularly useful to anyone, but we just try to do cool things, and doing things that are pretty common and useful. And so falls under a common and useful case. A lot of times you'll want to place a lot of objects on a surface. The surface may not be even, and you want to have them oriented in different ways. And so this is a basic way of how to set that up. So we're going to start with a new scene. I'm just going to click new scene. We already had a new scene, but I'm doing it again. And I'm going to go ahead and save it in our folder here. So we're going to go into our placing objects on a surface, and I'm just going to call this placing objects on a surface. All right. So what we're going to do is we're going to start with a surface to work with. And I don't want it to be just a flat plane because that's a really trivial case, and we want this to work on things that are not flat. So we're going to create a sphere, actually, to start with today. And we're going to make it bigger. I'm going to make it 100 by 100 by 100. I'm going to move it down by -50 so that it's kind of a place to stand on. And this will give us a little bit of a curve so that we can see how our stuff is working. So I'm going to go ahead and go into our standard assets and bring in a first-person controller. We're going to bring him into 000 and move him up so that he's on top of the sphere somewhere. 1.5 looks about right. And that gives him a little bit of clearance so that he can drop down and things can work. Which is kind of ironic because that's kind of what we're going to be doing with our placement. So let's see what we're going to do here. So what my proposal is, let me create a light as well, just so things look a little bit better. So let's hit play and just make sure things work. So we're on a sphere and I can move forward and stuff. Cool. And eventually, if we go far enough forward, I'll probably drop off the side of it. But we've got some range there, so this will give us an idea of how things are working. It also lets you see how polygonal the built-in sphere is, just because we've made it so large here. But that's okay. That's how it's supposed to be. So so what we're going to do is we're going to create a script. This is going to be a script heavy, not really heavy, but it's going to be mostly scripting. Randomly place objects on surface. So what we're going to do is we're going to have a couple of options here, although let's start first with randomly spawning things. So we're going to spawn things in the Z and X directions, and let's make it so that it's a, well, since we're on a sphere, it makes more sense to do a spherical based spawning. So let's just do a radius for right now. So we're going to do public float spawn radius. And we're going to default that equal to 10.0f. We'll probably change that. And then let's see, what else do we need? We need our object that we're going to spawn. So public float, public game object. And actually, let's make it a game object array so we can spawn multiple things and choose between them. Objects to spawn. And let's just start with that. So this is going to be all in start. This is going to be a one-time run type thing. And, oh yeah, number of objects. Let's do public int number of objects equals, what are we going to do as default? Do 10. So in start, what we're going to do is for int I equals 0, I is less than number of objects, I++. So this will loop through and give us 10 loops. It starts at 0 and goes to 9, so that's 10 loops. And we'll be able to now spawn the objects in here. So we do this. I want to save this. That's what I was going to do because it was not auto-completing. And hopefully, maybe if I save, it will figure this out. So what we're going to spawn is going to be random, so I'm going to go ahead and do a random between the objects to spawn. So what we're going to do is what we're going to spawning, what we will spawn. So I'm just going to create a temporary game object so to illustrate this easier as opposed to putting it in the whole line. We could put this in one line. It doesn't really make a difference speed-wise. But what we're going to do is we're just going to create a game object. Object to spawn equals objects to spawn, and we do random.range objects to spawn.length. So what this will do is this will give us a random object in our list here. If we only have one object, it will always give us the same object, but if we have more than one object, it will give us a random object in that list, or in that array. So now what we're going to do is we're going to actually spawn the object. So we're going to, let's go ahead and show where the position is. I'm breaking this stuff out so that it makes more sense. So vector 3 spawn position equals, and what we're going to do here is we want two-dimensional. So we have this tool called random.insideUnitCircle or sphere. Circle is actually what we want, but circle I think gives us X and Y when we actually want Y and Z. But let's just do this. Let's just work it through. So let's call it spawn position V2. So this gives us our position in XY space. So random.insideUnitCircle and times our spawn radius. Since this is inside the unit circle, this means it'll be anything up to 1. If we get multiplied by our spawn radius, we get it anything up to our spawn radius. So that works the way we want it to. Finally, we're going to create a vector 3 spawn position. This is our actual spawn position equals spawn position. I'm going to go spawn position V2. We'll just do that first. And then what we want to do is, actually, let's do it. So let's just do it this way. So we do it there, and then spawn position dot x equals spawn position v2 dot x, but spawn position dot z equals spawn position v2 dot y. So this transposes it in the way that we want. And so now when we instantiate, what we're going to do is instantiate object to spawn position. So that's spawn position. And rotation, we're just going to use quaternion.identity for right now. We will change this. So save. So what this will do right now is if we... Oh, we have a problem. No, about the range, it takes one object. Oh yeah, we have to say the range, so it's 0 to object spawns.length. So that'll fix that, and there's still another problem. Use of unassigned local variable spawn position. Okay. Oh, weird. Spawn position. Well, let's try this. Equals new vector 3. Actually, let's just do it in this line. So we'll use spawn position.x, spawn position.y. Actually, 0.0f. Actually, we'll use... Okay, so we have a couple problems here. 0.0f and spawn position.y. I just realized that. So this will only give us something that's just in zero space, and we kind of want this to actually be based on our transform space. So what I'm going to do is I'm going to actually add transform.position, and so transform.position plus spawn position. So if we hit save now, hopefully this will compile and everything will be happy. Yeah, it did. I don't know why it says all that stuff. Oh yes, because we have two main cameras. I'm going to get rid of our other main camera. There we go. So we're going to create an empty game object. I'm going to put it above the surface here just so we can see it working. And what we're going to do is we're going to call this randomly place objects on surface. This is not complete yet, obviously. So we're going to call this surface spawner. And if we give this an object, so I'm going to create just a sphere. Actually, I'm going to create a cylinder, because this will be more telling on what's going on. And we're going to place this into here as a prefab. That's all we're going to do. And we're going to then go to our surface spawner and put it into our objects to spawn list. So if we just drag this in here, it will automatically add one and put it in the list. So if we hit play now, we have some objects that spawn. They spawn the way that we expected them to, so that's good. So now we want them actually on our surface. So what we're going to do is we're going to raycast them down onto the surface. So we can... So we've already kind of put this in here, but I'm going to go ahead and create another term here. We're just going to do vector 3 spawn position relative to transform equals bam. So that's a really long, I'm going to call it final spawn position. So we're going to use final spawn position. Well, this is not the final spawn position either. So that's let's see, transform offset spawn position. Let's do that. And then finally, we're going to do a final spawn position. So what we need on that was we need to do a raycast. So we're going to do a raycast downwards. We're going to do raycast hit, and we're going to do if physics.raycast, and we do transform dot position, and we do vector 3 dot down, so that we're spawning, we're projecting downward. And we need a hit info, so hit, and I'm just going to go with that for right now. We could add more terms if we needed. And so what we're going to do here is we're going to do I'm going to create another new vector here called vector 3. Actually, let's not even do that. Let's do it in here. So vector 3 final spawn position equals and actually we don't want to raycast from transform dot position. We want to recast from here. There we go. So transform offset spawn position. Final spawn position equals hit dot point. So we place this now in our if statement. So if we don't hit anything, we just don't create the object. So that's actually optimal. So if you had a surface that kind of slightly exceeds or something, you could actually have it not hit that surface. So that's cool. And we're going to use our final spawn position now instead of our previous term here. So file save. So if we hit play now, we need to say out hit. That's important. Otherwise it will complain at us. Alright, so if we hit play, we now have objects on the ground. There you go. Now, they're sunk in halfway because we're using the object's transform position. So if we wanted to change that, what I would recommend is actually creating a parent object and offsetting it so that the base is where you want it. I'm just going to leave it for now. I wouldn't do an offset in code because if you do it in the art, it makes sense for the art. So if you have a character, it will stand on a surface. If you have a tree, it'll stand on the surface, etc. Now, maybe we might want to change the orientation on this in a few ways. So I'm going to create a couple of options here. So public bool random orientation equals false, and public bool orient to surface equals false. So what we're going to do is if we want a random orientation, so these kind of are mutually exclusive, so it's not the best choice to do bools. We probably should have a little pull down menu for that, but I'm not going to deal with that right this second. We're just going to do it as bools. And what we're going to do now is we're going to choose where it goes. So right now we're just using quaternion identity for the rotation. which is probably not what you're going to need in a final product. Maybe. In some cases it might work, but in a lot of cases you're going to want it to be either random depending on the type of object that you want. So like if you have a ball, like a beach ball on a surface, you'll want that just randomly oriented so it just looks like it was just placed there, right? But if you have something like sticking out of the ground, you might want it to stick out in the direction of the normal. So there's a few different ways that we can do this. So if, what we'll do is if we do random orientation equals true, equals, if random orientation, that's what we'll do. Then what we will do is we're going to create a quaternion orientation. So orientation equals random dot rotation. There we go. And so that's one. Else if orient to surface. In this case, we're going to do orientation. Is it one word on here? No, I think it's two. Hopefully that's how it works. Orientation equals, and in this case, oh yeah, we're going to need to put this inside here. So we'll do some final spawn position and we'll do the orientation stuff here. So else if orient to surface, in this case we're going to use hit.normal. But this is a vector, so we need to actually turn it into a quaternion. So quaternion dot look rotation hit.normal. And else we just do orientation equals. And actually, I'm not going to do quaternion dot identity. I'm going to use object to spawn dot rotation. Dot transform dot rotation. So this way you could change it in the prefab so that you get a particular orientation if you wanted. So if we save all of this, and oh wait, we need to actually use this now. So instead of quaternion identity here, we use orientation. All right. So save. So now what we're going to do is we're going to try a couple of these options. If we do random orientation and hit play, we should get these things in random orientations. There we go. So now we've got a bunch of junk laying on the ground, and that's cool. And then we could also do orient to surface. Now in this case, we'd probably want them to point up, but they're not going to. They're going to point onto their sides. They're all going to be on their sides on the surface. And the reason for that is the way that we've set up this object. So now let's actually show what I was talking about. So if we wanted this to be a particular way, we could create an empty game object, and we place the cylinder inside of it. And we're going to call this the cylinder, and I'm going to call this the cylinder geometry. And we could probably move up a few of these things up a level. The renderer is what we want to leave down, but I'm just going to leave it as is for now. And we're just going to move this thing up by 1 unit. So now when we move the cylinder around, you can see that it's at the very base here. The other thing I want to do is I want to make this forward. I want it to point up so that we can use the quaternion look rotation stuff easily. So we're going to rotate the cylinder along one of these axes. There we go. That'll work. And because of that, we have to actually reorient this again. So we need to make it so that the base is where we expect. So I'm going to put 0 here, and we're going to move it offset offset Z by 1. So now we have it at the base and it's pointing out. So if we do it this way, and we recreate our, object here, I'm going to delete this cylinder, and we're going to call it just cylinder. Doesn't matter, but I'm doing that. So we're going to delete this now, and we're going to go into our surface spawner and use cylinder. And so now if we hit play and we orient to surface, all of them will poke out of the surface like that. So that's cool. And we can collide with them. Awesome. So now we've got posts sitting in the ground. So that's how you basically place some objects. And so we could again, we support multiple types of objects. So if we wanted to have spheres in there as well, we could just create a little sphere here. delete the one in the scene, go to our service spawner, put our sphere on top of it, on objects to spawn, and let's make it so that we spawn like 50 objects, and we make the radius a little bit bigger. Let's make it 20. So if we hit play now, there we go. Okay, so there's an interesting one. We had an object spawning on top of an object. We can fix that with a layer mask, and I think I will leave that as an exercise for you guys. So adding a layer mask, we've done it many times before. Just create a public layer mask variable and feed it into your raycast, and then we can mask what layers actually it will interact with. And so you set the sphere to a layer and do that. As I said, I will leave that as an exercise to the viewer. So thank you for watching. Hopefully this was useful. If you have any questions, comments, concerns, anything that doesn't start with a C, you can email me pushypixels@pushypixels.com. You can also tweet me at Drakfire. That's DRAKFYRE. Please donate to the show on Patreon. It's patreon.com/cookingwithunity. We really appreciate your support, and by supporting us, we will give you access to the Cooking with Unity super repo, which has cool stuff in it. Thank you very much, and you guys have a great one. I'll see you tomorrow at 9 a.m. for our new standard time of Breakfast with Unity. Thank you very much, and see you guys.